manuals as they affect the automotive air conditioning people. We're also going to get into multimeters and take a little bit of an idea of what multimeters do and what you need to look for if you're going to go buying a pretty decent quality one or buying a multimeter. Off and on. Wonderful. There we go. Maybe that'll work a little bit better. Oh, I can't seem to win today. Okay, this is me. So much for that. I'm Topper, and Simon's pretty well introduced me. First of all, I like to come up with a scenario of what happens when a customer comes in for a complaint. But before I do that, I guess I better do my thing, otherwise Paul will sit over here and get unhappy about me not doing it. He's come to expect it over the years. I don't have all the answers to everybody's questions, and I don't hope to be able to answer them, but I'll do my very best, and I have a whole book full of information, a computer full of information that will help us if I need to turn to that and turn to other people. If you have questions, normally I say stick your hand up and ask them right then. This meeting is of such a size we can't do that. I will be on the floor of the show today and tomorrow, so if you have questions, please feel free to ask me at any time after the meeting's over so we can go on. Simon's limited me on time, so we're going to move forward as fast as we can. Okay, the customer comes in, and the customer's complaint is what? It ain't cooling. Well, what do you mean it isn't cooling? It ain't cooling. Well, what's it not doing? It ain't cooling. If I keep asking him a stupid question, he's going to keep coming up with the same stupid answer. Well, is it blowing hot air? No, it ain't blowing no air at all. Well, I'm going to start looking for a blower motor problem. Yeah, it's blowing air. It's blowing hot air all the time. Okay, then I'm going to start to look toward a refrigeration problem. In this day and age, where we no longer turn on the air conditioner ourselves, we get a choice. We ask for air conditioning. A signal goes to the computer. The computer then checks 3 or 4 things, holds a board meeting, votes on it, and decides whether or not it's going to turn on air conditioning. Once it decides that it's going to turn on air conditioning, it sends a command down to a relay to do so. If everything's successful, all the parameters are met, we see that there are air conditioning. Where do you get started if we don't have air conditioning? All right? Get as much information as you can from the customer. And here again, that's what I was talking about just a second ago. If you don't ask the customer intelligent questions, he's going to keep giving you the same stupid information. Start the car, turn on the air conditioning system. Determine if the AC clutch is engaged. Alright? If the AC clutch is not engaged, turn off the engine and hook up gauges to make sure that we have a sufficient amount of pressure in it to cause the system to work. If pressure is sufficient that the AC clutch should kick in, whether it's enough to cool or not is up for grabs, but if we have enough to kick the clutch in and the clutch is still not engaged, probe both sides of the AC clutch terminal with a digital multimeter or a 12-volt test light. You can still use standard old 12-volt test lights in certain applications. Alright? Why do I say probe both sides? If you have a bad ground, an open ground, you'll have 12 volts going to it and it isn't working, and you can spend a day and a half playing around on a vehicle that has no ground circuit. Ground circuits in computerized cars are more critical today than ever before, and you're looking at a person that probably spent about 3 hours on one here about 6 months ago, which had a broken wire at the ground terminal somewhere on the engine. And the only thing was wrong was the clutch wouldn't kick in. So check both sides. If you see voltage or a test light on one side and not on the other, then you probably have a pretty good idea the clutch coil is not up to standard. You see no light on either side, it means that the relay that turns the clutch on has not turned on for whatever reason. If you're seeing a test light that lights on both sides, you're seeing a bad ground. So you start looking for your ground circuit problems right then. All right? Moving on. If no voltage is at the AC clutch, turn to your information source. Now your information source can be varied. You can have a manual served by many of the manual companies available today. You also can very readily access computer information, and computer information can be real handy. I keep one handy. It'll come up in just a second if everything works like it's supposed to, so that I can access information anytime it's necessary. That is one good way to do it. There are also some excellent services out there which allow you to call when you have a particular problem that you can't get a handle on, charge you so much a minute, and some of these, for those that don't spend a whole lot of time on the technical side, are very advantageous. Why should I spend 5 hours getting to the root of a problem when somebody for 12 bucks will tell me what that is? Doesn't make good sense to me. Also, I developed my own little network of about 4 or 5 techs that are real friendly with myself, and of course I call on them, they call on me, we move it back and forth, and those techs and I bounce stuff off one another whenever we have a serious problem to see if maybe we're just stuck in the woods somewhere and can't see the trees. 9 times out of 10 that works for me. But there's GTE Capital, there's Aspire, there's 3 or 4 companies out there that have good troubleshooting information. It pays for you to have a fax machine readily available if you're going to talk to those people so that they can send you diagrams, troubleshooting trees, whatever's necessary to do it. But I wouldn't hesitate in spending a few bucks to find them, build a customer for them. That's better than spending 3 days to find a problem in a vehicle. Quite regularly, I spend as much as 2 and 3 days on finding a particular problem with a couple of techs. I complained here to my wife here a while ago. I said, you know, every vehicle I work on takes 3 days to fix anymore. This is really getting to be tough. She said, no, it doesn't. She said, people call you all the time and you fix them in a minute. You don't count those. That's probably true. Ones that are easy we don't remember, but the ones that are hard we remember quite well. So information source, that'd be a whole 2 hours in itself as to where you could go, how you would go about getting it, but you need to avail yourself to all of the information that's available. There is no way that anybody can keep all this stuff in their heads. The first mechanics were blacksmiths. How about most smithies? Could they read real good? Most of them couldn't read at all. And they had to start a dirty rumor that's persisted from that day to this. Any mechanic read out a book don't know what he's doing. And from that day to this, everybody's been scared to death to pick up a book to do something. Well, I can tell you that there's no way you can survive today without good technical data. After locating the clutch relay, and that's what your information is going to tell you, you then need to check the clutch relay. Here again, if we're checking the power side of the relay, that can be done with a 12-volt test light without doing any harm, if you know which terminals are which on that relay. If you are checking on the driven side or the operational side of the relay, you can put a sufficient load on computerized circuits with a 12-volt test light that you can have some serious problems. Here again, a 12-volt test light to check no more than a light is fine and dandy. But when you go to probe computerized circuits, again, if you get on the hot side, you get on the driven side, that's fine. You get on the operational side of the circuit, oh my God, oh geez, quick. You've got to catch as much of the smoke in a bag as you can catch. That way when it goes back to be repaired, they can grab hold of a syringe, take the smoke out, and try to put it back into these little tiny components. Consequently, boy, it sort of went away, didn't it? I hate when that happens. But it was all right. It's all right. It was gray smoke. If it's red, if it's gray, if it's gold, that's okay. If it's green, you're in deep doo-doo. I mean, there's no problem. You're going to have to do some major repairs. All right. Moving right along. We want to use digital meters and good test equipment anytime we're checking on a computer-driven circuit. All right? If the circuit is not completed at the AC clutch activation terminal, and bear in mind that circuit at the relay can be either grounded by the computer or powered up by the computer, depending on the vehicle that you're working on, then we want to hook up a scan tool and check for fault codes. Also, check the scan tool to see if the clutch has commanded the air conditioning system on. Here again, has it made its vote and has it decided it's going to run? Scan tool, or the computer, can keep the vehicle from running for a number of reasons. There are many different types of scan tool. Here's one by Bosch, about a $3,000 piece, primarily foreign cars. Here's one by Hickok, used primarily by Ford, also sold by one of the parts company. Pretty nice unit. Also has scope patterns. We see that the old Tech 1A and Master Tech by Vertronics. Tech 1A was the standard tool for General Motors for a number of years. Now, the Tech 2 is the new thing in the marketplace. MPSI. And MPSI has a real nice setup in that they have some enhanced diagnosis that lead you to where you're going as far as the problem is concerned. Here's MPSI's newest deal, and it's about a $5,000 unit. It's virtually a laptop computer, and that's their latest scan tool. They call it the next generation, and it's a nice piece. Here's the OTC unit. I've worked with some OTC units, and I can tell you that they have some advantages if you're going to do other things in the business, particularly, in that they can be expanded to do emissions work, IM 240 testing 4 and 5 gas, and they also, in their enhanced 4000, and that slide's real hard to read, and I'm sorry for that, but they have a definite path of information which will lead to the conclusion of fixing the vehicle. And not all have that. Some scan tools just give you the information. You need a fault code or a manual to go with it, and you need to fall down through it. This particular tool will find the parameters that are out of specs and bring them up for you. It scans all of them and says, hold it, the O2 sensor's wrong, or hold it, we don't have enough battery voltage. I've had vehicles come in, air conditioner not working, that's why the customer drove it in. We check, no clutch engaged, and put a voltmeter across the battery, and it's reading 11.5 volts. We checked the battery out thoroughly. Fortunately, this car is a real easy starter, and it would start in our wonderful Florida weather down here, where I live, with one dead cell in the battery. It managed to get started every morning. But the low voltage, computer seeing that, voted against the air conditioning clutch being turned on. It said if you've got that low voltage, there's a good chance you're going to walk real soon. If you turn the air on, you're going to walk sooner. And we don't want to do that. So it didn't turn it on. We did no more than bolt a battery in the vehicle and fix the air conditioning problem. That was a hard one, wasn't it? If you were looking with the gauges, you'd have had a hard time with it. Here's another scan tool, and it has expandable capabilities. Almost all of them have some form of capturing a glitch or snapshot capability. Turn the lights up just a second, if you would. Snapshot capability, basically, is kind of like an old money changer that's about half full. Money keeps coming out the bottom and pictures keep going in the top. Pictures come out the bottom and pictures go in the top. Pictures go out the bottom, and that's going on continually. When you hit the capture, it stops right there and fills up the changer. Now you have the information before the fault, during the fault, and after the fault. So you can see what led up to the fault with snapshot type capability. Any questions? What's that? Oh, thank you.
Boy, I got more stuff up here and I don't know what to do with it. Sure hope it doesn't rain. Okay. What scan tools do? A scan tool decodes serial data from the onboard diagnostic link connector. And here is an oscilloscope pattern of that diagnostic code. If you can count real fast, you can tell what the signals are, and you don't need a scan tool. But I haven't been able to count that fast. I don't think anybody else can either. But that's a serial data line. It's just a lot of noise on the line. If you listen to it, it'll sound like a fax machine. And basically, it is the information which is being sent to the different components and the data bus line in the computer. It is what the scan tool uses to capture the information that you're looking at. Some scan tools are bidirectional capable. If they're bidirectional capable, they not only can take information out of the scan, but they can also put false parameters in to force something to happen. Not all scan tools have the bidirectional capability, and it sure is handy when you go to looking for a scan tool to have that bidirectional capability. Here we see a composite system, and it shows all of the different relays and some of the sensors on a standard setup. I think ASE for this particular slide, in that it is the composite used for the L1 test. But basically, the information comes down to a data link, and there's a couple of different types of data link. The old was the ALDL. We'll look at this wiring diagram about that in just a minute. This is the new Onboard Diagnostics 2, OBD2, and every vehicle built will have this type of connector in it. Be it foreign, be it Rolls-Royce, it's sold in this country, it has to have one of these connectors. Certain tests are going to be standard. They're standard SAE tests. The manufacturer can then add other fault codes above and beyond that. In some cases, i.e. General Motors, if you went just by OBD2 standards, the GM guys would be backing up. They've got more information and have had for years. But it's going to make some other people move up, and there's going to be certain information available to us that was never available before. It's going to be handy in diagnosing particularly drivability complaints. All right. Here we see the diagnostics of an old ALDL connector, but basically what I want to show you on this particular one, Simon was handy enough to give me a pointer, so I can do that now. Ooh, boy, I shake. Okay, first of all, we've got battery voltage coming in. I can't even hold that. I'm going to make everybody in here drunk. All right, we've got a signal coming in for trouble codes. We have a ground signal, and we have a serial data signal. There's also a battery voltage signal on there also. But if you take on the old systems and put a jumper wire between here and here, paper clip, key, anything else, it will give you the codes on the vehicle with the check engine light. Also, it's a good place to start if your scan tool, when plugged in, don't work. Anybody ever plugged the scan tool in and the thing was so fouled up, nothing happened? Well, that'll happen when you have a bad ground for certain. If you put your jumper in there, hook from that jumper wire that's going between the two, that means that there's a load on the ground, to ground on the battery post. You should have no more than 50 millivolts, 0.05 volts, reading at that terminal when it's shorted across. If it's higher than that, the vehicle has a bad ground. You can also check the TPS switch, a couple other places as far as quick get-ins for bad grounds. But I'm here to tell you that probably a full third of the problem vehicles with computers that I work on happen because the ground circuit is not functioning as it should. In fact, there's one particular manufacturer, I won't even name names on that one, but I tell them when they call me with a problem, go and loosen all of the grounds that you can find on the engine and the chassis and tighten them a half a turn. I'd like them to take them off and clean them, but I'm more practical than that. Just loosen them and tighten them a half a turn and call me back if it don't work. and they don't call back. So obviously it worked pretty good. Digital multimeters, DMMs. We used to call them DVOMs. I hate acronyms personally because it ends up getting confusing. We've got a book of acronyms that have come out of a couple of the car manufacturers that are this thick, 1.5 inches thick, double spaced, and in some cases the same acronym suffices for 5 different things. That's a little scary, but yet we find engineering trying to shorten up language all the time and using them on a regular basis. All right? Digital multimeters, and the reason they aren't DVOMs anymore is most of them have more than just a digital voltmeter and ohm meter involved, or milliamp meter. They have many other functions capable. All right? The major difference between an old analog meter and digital meters is the amount of current drawn by the meter in the circuit being tested. The extra features that extra features can be added to the DMM. Turn the lights up if you would, please. Here are some super high quality analog meters. In their day, this particular set was worth about $5,000 in 1960. It was a stout price. This, at one time, was the standard as far as making electronics checks in the electronics industry. And slowly but surely, digital meters came around with much less draw. And the reason that there's much less draw is they don't have to physically power anything up. The old style had to make the pointer move. When I first started in this industry, if you had a voltmeter that had 1,000 ohms per volt resistance between the 2 leads, you had a good quality piece of equipment. Today, on a digital multimeter, if it is less than 10 megohms, we tell you don't hook it up to an electronic circuit. I could have hooked a digital meter up to this same circuit that just blew up and nothing would have happened. But a test light caused it to blow. All right? Here we see a digital meter and a block diagram of that digital meter. I can run through it real quickly and we'll confuse everybody here, but basically the signal comes into an operational amplifier. It then leaves that and goes to an A to D, analog to digital converter, on up to a microprocessor, on up to a segment driver, and you've got a digital meter. Who cares? What I want you to know is that digital meters read differently. You can hook 3 very good quality digital meters up to the same circuit and get slightly different readings. And you say, how is that? If there's any variation on the voltage of that circuit, how the meter reads is going to show up. Some of the meters take 3 signals within a period of a second and average them out and give you 1 reading. If it showed everything, the last 3 digits would be a blur all the time. It'd look like everything was 888. A dim 888, but 888. They'd be moving all the time. Instead, the digital meter what? It averages. How it does that averaging, whether it takes samples or averaging, will come up with how good it reads on a circuit with a varying voltage. If you put it on a 5-volt pulse width circuit on a DC meter, you'll see 3 or 4 different voltages from 3 or 4 different meters. Every meter will read something a little bit different because you're asking the meter to read faster than it probably can do a good job of. All right? With that in mind, if I can find my slide beeper. Features that are a must for a digital multimeter. And I'm going to be handing a handout. It's going to be handed out at the doors as we leave here. And basically, it will expound upon all of these features. And this is one of the slides that are in it. The voltmeter must have a 10 megohm impedance. This is no more than the resistance between the 2 leads. All right? A diode test position. Digital meters have so little current flowing through them and they work on so little voltage that they can't properly power up a diode to check it right. So they have to have a circuit which checks diodes separately. With an old analog ohm meter, we could check a diode with no problem. It had a high enough voltage in the battery inside the meter to make that happen. We don't have it available on digital meters anymore. A fused 10 amp scale. A lot of the laboratory type pieces of equipment have milliamp meters, but they don't have 10 amp scales, which is necessary for checking some of the relay draws in automotive usage. Auto ranging lockout. That may not be an absolute necessity in your book, but it sure as heck is in mine. Auto ranging will get you messed up more than it'll help you. It's nice to be able to hook the meter on and get some kind of a reading, but when you're using it in an ohm meter, are you measuring 4 ohms, 4,000 ohms, 4 megohms, or 4 apples? I don't know which. When I have it locked down, I know what I measure. So I want to see an auto ranging lockout. All right? Features to be desired. Analog bar graph. This is very helpful in being able to see a varying voltage. In other words, that the meter's averaging out and you're seeing a steady voltage, but actually it's moving back and forth. The bar graphs usually move around a little bit more. Dwell reading, because you will still use dwell readings in certain settings and checks in automotive usage. Duty cycle percentages, which are going to be more and more mandatory. Min-max measurements. Pulse width measurements in milliseconds. Features of a great DMM. K-type temperature probe leads. Great for an air conditioning shop. Frequency measurement. Capacitive testing. A low ohm scale, which very few offer. An auto shut-off switch, which is real neat in that it saves you a lot of batteries. Or it saves you having a dead meter if it has NiCads. The last one I put in a little bit bigger print, and I did it for a reason. True RMS. There's only about 2 tests that I know of that we use true RMS. But when you add that to the quality of a DMM, you automatically add $100 to the price of it, and you get a better quality piece. Any questions? Let's turn the lights up a second. We can start out real inexpensively. This is a $25 DMM from Radio Shack. But will it hold up in shop usage? I don't think so. Does it have a 10 amp scale? No, it don't. But as far as just making a circuit continuity test, a 10 meg ohm voltmeter and a ohm meter, it does an excellent job. And you can carry it around in your pocket. There's also logic probes do the same thing. All right? From there, you can move up to one made by Fluke, 250 to 350. A couple made by OTC that have more features than you can shake a stick at. They're real handy in that they have a lot of additional features, the K-type temperature probe, and do things in the automotive field because they were designed for automotive use that are real handy. They've got a 500 and a 700. Theirs range from like $250 up to $600, but with that $600 you get a kit of probes and pickups that don't come with some of the other meters. And again, all the prices I'm quoting are basically approximate. With DMMs with digital oscilloscopes, we see that there's a tech meter. We've got a tech meter up here, and you're free to look at it after a break. We have the Vision from OTC, and here again, as far as user-friendly capabilities, this one, while it doesn't go as fine as I'd like it to go on the oscilloscope scale, because I'm a nut, not because it isn't good enough, but I'm a nut. I want to see more all the time. This one, as far as ease of hookup and getting to use it, is a snap. And believe me, there is a learning curve when you start playing with these things. It also can measure 4 frequencies or 4 channels and can make more than one type of reading on a channel. You can get 6 possible readings out of that at the same time if you want to look at a bunch of different stuff. Well, it has some real features. There's one of those sitting up here at this time too. Alright, here we see a Fluke scope meter. They were one of the first to get into the digital multimeter, which also was capable of showing scope patterns. Used on 1 channel, very good piece of equipment. Used on 2 channels, its speed goes down to some degree. At least not its older ones do. I don't know what their latest ones are. Here's one by Tektronix. It's somewhere in the neighborhood of $1,800 to $2,000, and it's, you think, kind of expensive to pay for a digital meter. It's not only a digital meter, but it is an oscilloscope. And you can run the cost of this thing up a whole lot. We can get into CRT screens, and if we're talking about CRT screens, we see that this little handheld oscilloscope is somewhere in the range of probably $3,000 to $3,700. And everybody says, oh boy, that's really stout. Huh? You want to see stout? Here's stout. This one's about as big as a small suitcase. Not really, it's about as big as a battery. And that one is $8,000 to $10,000. It is a laboratory piece of equipment. Turn the lights up if you would, please. Here we have an old analog scope made for the military, and it's a lug to haul around, and it only takes a picture of what's happening right now. It don't save anything. Digital scopes do the very same thing, and this is the replacement piece in the military for that one, do a fine job, and they are able to record 6 or 8 patterns. All right? When it comes to buying meters, this particular voltometer, or DMM, it was DVOM when I bought it, this has traveled more than probably 4 million miles with me, and I've had it for pretty close to 14 years. When I first bought it for $585, my fellow instructors and compatriots thought I was out of my tree to spend that much money of my money for a meter. Later, when we got the standard of 10 megohm impedance, I said, oh shit, I gotta buy a new meter. Went home, got out the instructions, and guess what it was 10 years early? 10 megohm impedance, didn't have to buy anything new. All right? Eventually, I've gotten to the point within the last year that I've weaned myself from traveling with this and started traveling with this. But it took about 6 months of taking both of them because I still trusted this. This was an old friend. First time I left it at home, I almost cried. All right? And when you get into using anything that has an oscilloscope attached to it, you better be willing to invest a considerable amount of time in learning how to use it. You don't just pick this thing up like you do this one and use it. It takes time to get used to it. You've got to study the stuff that comes with it. To give you an example, I've had this for about 2 years. I am to the point where I am very comfortable with it. I like a lot of its capabilities. And if I haven't hit the wrong thing on the screen here, somewhere hit enter. It has the capability, after it wakes back up, of taking patterns and putting them on a screen and eventually being able to show you what those patterns are and comparing them to good ones. Sorry. Okay, that pretty well winds it up for me because we are at a time constraint. This is not the full program that will be offered this spring, but it gives you a real good thumbnail sketch. And when the program comes around, you won't see all this equipment. This was assembled strictly for this show. We put on a little bit more here than normal. But basically, this is what is needed to get into the automotive electronics testing. You need some form of heavy load testers if you're going to test batteries. And even if you're working on air conditioning, you have to have the ability to test batteries. So you need a heavy load tester. All right? You need some form of a digital meter. And there's a bunch of good ones out there. Do you need oscilloscopes yet? No. You don't have to have them, but they're damn handy. There are places where you're getting varied readings or noise on a line or ground levels that are elevated that you will only find with an oscilloscope. About 2.5 years ago, I spent about 4 days working on one particular S10 pickup truck, 4-cylinder, cast iron tube, 1990, with a no-run problem. And this shouldn't be hard to find. Most parts replacers would have found it in a heartbeat. But the bottom was that the substrate in the distributor for the Hall effect switch had been rubbed on a little bit, and as it got warm, it elevated the ground level. And after we finally got to the bottom of that with an old analog scope, I came home and said to my wife, this is real simple.
Either I've got to stop teaching altogether in 2 years because I'm going to be old hand and I won't be a has-been, or I've got to spend about $20,000 in test equipment just to teach for the next 10 years. She said, God, do we have to spend it all at once? I said, no, we can spend a little bit at a time. And I can tell you at this point that that bill is now up to about $40,000, but I said before I was a nut. I'm an equipment nut. Everybody, ladies and gentlemen, thank you for your time. We're under time constraints.
Here, he's a right hand to us, he keeps us straight, and without further ado, we're going to invite the panel to assemble. Mr. Mola.